Here is a Softrock Ensemble. I'm running it with Linrad, and here are the transmit control windows for it. I'm going to calibrate the signal level first, and the best instrument I have for that is the oscilloscope. It's on 50 ohms input, and here you can see the level. It is a little bit higher starting, but after a few seconds it's at 19.8 volts peak to peak. And it's about 20 volts when I'm keying it. Like something like that. Well, even a little bit more. So the power starts a few tenths of a dB above 1 watt, and after a while it's 1 or 2 tenths below 1 watt. 20 volts peak to peak, that is 1 volt into 1 watt into 50 ohms. I have set the bandwidth of 2.4 kilohertz. I can check that by moving the BFO. You can see here the first 3 dB point is at 7039, and here we have 7041.4. So it's close to 4 kilohertz bandwidth, which is a standard for measuring things, I think. Normal SSB. I have calibrated the S meter, so when I press the key, you can see the signal comes at 30 plus 0.3 or something, and then it drops to 29.7 or something. So it's close to 1 watt, and now I think the S meter is properly calibrated for this Softrock. And it's normal. Some heating affects the power a little. The signal is on 7041, so I move about 20 kilohertz. That's here. 7061, like that. Sorry. I have to be a little bit careful because the frequency indicated is the frequency of the carrier, which is the BFO frequency. But now I'm 20 kilohertz away, and I press the key, and you can see the noise floor increases. I don't see anything on the S meter because the scale is so expanded. I have to contract it. Now I can see the noise floor 20 kilohertz away. It's at minus 78 dBm in 2.4 kilohertz bandwidth. This is pretty good. So this is 78 plus 30, because that's the power, plus 30 dBm, and then 34 dB for the bandwidth. It gives me 142 decibels per hertz below the carrier, minus 142 dBc per hertz. This is with a delta 44, but it's not directly from the sound card. I have an attenuator here to be able to run the delta 44 at its full range or close to that. You can see I have it set to 94, which is pretty close to the upper range, which is 100, I think. I have removed the attenuator now and turned down the level of the Delta 44 down to 56 in this ALSA mixer program. It gives me again plus 30 dBm on the carrier. Now again 20 kilohertz away. The noise floor is about 69, so it has degraded significantly, and that's clear from the main spectrum. You can see the noise floor is lifting on all frequencies. These are the sound cards available to the system at this moment. The HDA Intel is now used for a receiver loudspeaker output, but I will try to use the SSP Live Value to drive the Softrock. That's number 6, and I run it at the maximum frequency, 96 kilohertz, and 2 channels because I'm sending I and Q to the Softrock. The SSP Live Value CT4780 gives quite a bit more noise. This is what I see on the Perseus screen. Pressing the key. The power is 1 watt. I was setting the level to give 1 watt. 20 kilohertz higher in frequency. Here the noise floor is let's say minus 59 dBm. This is not quite as good as the Delta 44. It is minus 123 dBc per hertz. And you can see on the main spectrum that the color we have here is for about 200 kilohertz. That's the widths that we pollute with this noise when using this particular sound card. Now I have selected the motherboard sound card, and this looks not so nice. It's like this. It's reasonable near the center frequency, but it has a lot of noise about 150 kilohertz away. 20 kilohertz away here, the level is minus 73 dBm in 2.4 kilohertz bandwidth. Not too bad. But at a larger frequency separation, it's only minus 63 dBm. And I think that's not acceptable. This motherboard sound card should not be used together with a Softrock transmitter. This is a low-cost USB audio device. It behaves like this. And you can see on the spectrum there is a lot of noise. This is not what we want. Going out where the noise is strong, you can see the noise floor is at minus 50 dBm. And this is in 2.4 kilohertz bandwidth. In ALSA, this sound card is specified as VIA Technologies Incorporated USB audio device. I think this is fairly good to use for a receiver, but not for a transmitter. unless a filter is added to remove noise above a few kilohertz. This is a Steinberg UR2. It behaves like this. So I have set it to 1 watt. One has to use this adjusting knob. There are no digital controls for this unit. And if I go 20 kilohertz up here, the noise floor is at minus 70 dBm in the 2.4 kilohertz bandwidth. Not too bad, but not too good either. But we can see in the main spectrum the noise is strong pretty far away. I have to look a little bit further away, so I click on the frequency control here. Go up 100 kilohertz. And then I can see the noise has a maximum about, 300 kilohertz up. Oops. That's about here, where the level is minus 66 or so. This is a sound card of unknown origin. I got it from HB9DRI. I think he's using this chip now in his IQ Plus. This is how it behaves. And it doesn't look so nice, but if I check 20 kilohertz from the carrier, kilohertz away, the noise floor is at minus 70 dBm in 2.4 kilohertz. The shape of the spectrum fits well to use this card together with the low-pass filter that removes all noise above 5 or perhaps 10 kilohertz. So the ugly peak about 60 kilohertz away would disappear completely. Here is another USB sound card. It behaves like this. 1 watt, and this is the noise spectrum. I go away 20 kilohertz, and the noise floor 20 kilohertz is minus 54 dBm, or close to that. And you can see on the screen we are on the noise starts already 5 kilohertz from the carrier, and even at the carrier it is pretty high. Here the noise is minus 48 or something like that, and it's about 100 kilohertz away from the center. This sound card absolutely needs a filter if it would be used. This is a Terratec DMX6 Fire. It looks like this. A lot of noise. If I go 20 kilohertz to the side, like that, then the noise floor is 68 dB. That's minus 68 dBm in 2.4 kilohertz bandwidth. The noise peak it's here. It is a power level of minus 27 dBm. That is a very high interference level, so this unit should absolutely not be used for a transmitter, at least not for somebody who is using the Softrock Ensemble as a exciter for a transverter to the VHF range. This is an AAI E-Pro, and it behaves like this. I've set it, of course, to 1 watt. So I will look 20 kilohertz to the side. And this is the noise floor. It's about minus 65. But there are irregular things, small carriers coming and going. I haven't seen something like this on any other sound card, but I don't know what to say about it. Anyway, the noise floor close to the carrier is not particularly low, but at wide separations it's much better than many of the cards I have tested. There is one thing to observe with this card. What you saw just now was with this knob on maximum and then the level set here. If I do it the other way around, turn this to maximum and set the level by that one, I get a different result. Now the knobs are like this. The power level is 1 watt and the spectrum looks like this. And 20 kilohertz away, the noise floor is like that. Now I happen to come on one of these spurs, and that's unfair, so I move a little bit. Let's say like that. So we are at about minus 60 decibels now. I have turned down the signal level by 20 decibels here, and then I do continuous carrier like that, and look at the signal 20 kilohertz away. With the master level turned maximum, when I turn down the monitor level, this happens. You can see the noise increases while the signal decreases. So turning down should be done with the master level and not with the monitor control. This is a complete Audio 6. And it looks like this. And it was 1 watt. And the noise floor is minus 52 dBm, 20 kilohertz away. And it has a maximum another 5 dB and a sharp maximum even higher. This particular sound card cannot be used with Linrad, because if I close it and try to reopen, the system will crash. There is something wrong with the driver for this box. This is an MTR Quad. The volume here should be maximum, and then one would set the level with this knob to get the optimum noise sidebands. 1 watt, and this is the spectrum. 20 kilohertz up, it looks like this, minus 64. But there are problems with glitches. And this was under Windows 10. Now I have the MTR Quad running under Windows 7, and I don't see any glitches here. And it's 1 watt, 20 kilohertz up. That's here. We are on a spur that comes and goes. Between that coming and going of the spur, we are at minus 67. And I can move to somewhere where the spur is not. And we can see the level is... This is similar to one of the other sound cards. I have forgotten which one. The noise is a little bit high close to the carrier, but not so high further out. The MTR Quad is, however, useless with Linrad. I have it now running as the transmitter, and I can do the keying. But if I exit and then go back with B here, this what happens. It's the same behavior that I see in complete Audio 6, but in no other sound card yet. Now I am keying a Maya 44, a PCI sound card, 20 kilohertz up. The level is minus 67 dBm. And I have to set the level in the control box for the Maya 44 to minus 10 dB. It means turning up by 10 dB here and attenuating by 10 dB would give a 10 dB improvement, provided that the Maya 44 is sufficiently linear. I have not checked that. Here is the DMX6 Fire PCI card. It suffers from glitches, but otherwise it looks pretty good. I will check 20 kilohertz up. Between the glitches, it's 68 decibels. That's minus 68 dBm is the power in 2.4 kilohertz bandwidth, while the carrier is plus 30 dBm. I don't know about the reason for these glitches. I have tried some different settings. Running under XP32. Maybe some other Windows version would do better, I don't know. This is an old card, so I don't think it will work under Windows 10 and possibly not even under Windows 7, I'm not sure on that. This is a Sound Blaster Audio LS at 1 watt. The noise floor is fairly flat. I will look 20 kilohertz away. And here we have minus 65 dBm in 2.4 kilohertz. Not too bad considering that this is the level we have on all frequencies. The playback control is at 48 only, so there is a big margin until full DA range. This is M Audio Revolution 5.1. 1 watt. 20 kilohertz away. It's here. The level is minus 55 dBm. There are some glitches, not many. Maybe I could remove those by selecting different parameters, but performance is not really very interesting. Maybe when trying this, looking for another important parameter, which is the latency. This is a PCI card, so it is faster than USB cards, presumably. These are the settings I was using.